All right, welcome to finding equations of tangent lines. So we've beginning to look at the different rules of differentiation, like the power rule, the product rule, and the quotient rule, and we've also used our very long definition to find derivatives. And what we're going to do in this section, or this concept here, is really extend on that idea. So instead of just finding the expression for the derivative, we're actually going to take it another step further and actually find the tangent line that goes through a given point. Because a derivative is the slope of some tangent line at a specific point. Well, we want to find that equation now. So there's a couple steps I've outlined to help you. So number one, if you're finding a tangent line of a function, you've got to find the derivative of that function. That's number one. Okay. So number two, once you find that derivative expression, you have to plug in the given x value into f prime to find the slope. So you're going to take the derivative, you're going to have an expression with a variable. Most of the time it's going to be x. So what you do is just plug the x I give you into f prime. That's going to give you the slope of that tangent line. Now, in number three, once you have the slope, you can either use the point slope or slope-intercept form to help you write a linear equation. Remember, tangent lines are lines. They can either be written in slope-intercept or point-slope form, and we're going to do both in this section. The other thing that you have to remember is that if you're not given the y-coordinate, you've got to find the y-coordinate first. So these steps may be a little bit tricky and you think, oh, there's a lot going on here, but let's look at an example to see how it looks. So number one, find the equation of the tangent line to f of x equals x squared minus 2 when x is 2. So now let's look at that. I've got my function and I've got an x coordinate, but I don't have the y coordinate. Remember, to find an equation of a line, we either need point slope, we need a point on the line and the slope, or slope-intercept form. So let's find the y coordinate first. So in step number one, find f of 2. So when I plug 2 into this original function, I get 2. So my ordered pair is 2 comma 2. Now we go back to what our first slide was. Now that I have my coordinate, my xy, I'm going to find the derivative. So find f prime of x. So we're going to find the derivative of the function given. So f prime of x is equal to the derivative with respect to x of our function. Well, apply our power rule. The derivative of this is x squared is 2x. The derivative of a constant is 0. So there is the expression to find our slope. That's our derivative. Okay? So step one is done. We took the derivative of our function. Step two says, well, plug in your x into this answer, and that's going to give us the slope of our line. So find the slope. We plug x equals 2 into 2x. So 2 times 2 is 4. That's the slope of the tangent line at this point. So we have the slope, and it's 4, so now we got to write the equation. So I'm going to use point slope form, and most of the time the text will too. So here's point slope form. Y minus y sub 1 equals the slope times the quantity x minus x sub 1. Y1 and x1 are the point of interest. Okay? This y and this x can be any other point. So, by substitution, we have y minus 2 equals 4 times the quantity x minus 2. There's our y coordinate, there's our slope, there's our x coordinate. Simplifying, we get y minus 2 equals 4x minus 8, and we just bring the 2 over. So y equals 4x minus 6. That's the tangent line that runs through this point, 2, 2. Okay? That's the tangent line. That's what we're looking for. Okay? So, number one, we found the ordered pair by plugging in x into the original function. We found its derivative. We plugged our x into that expression, and we got our slope. Then we took our point and our slope and plugged it into the equation and simplified. So let's look at a few more examples. Okay, so another example, we're looking at finding the equation of a tangent line to y equals x squared minus 2x plus 1. Again, I used x equals 2. Okay, so I'm looking at this and I say I've got a function, but I don't have a y-coordinate. So I have to find a y-coordinate first. So we plug in 2 in for x. So we plug in 2 for each x, so we get 2 squared minus 2 times 2 plus 1. Well, that simplifies to be 1. So when x is 2, y equals 1. I've got my point. So now I need my slope in order to write a linear equation, a tangent line. You need point, you need slope. I've got my point, but to find the slope, I have to first take the derivative of my function. So we could say y prime here, and I should have said that. So we take our derivative of our function. The derivative of x squared minus 2x plus 1 is just 2x minus 2. Now I plug my x coordinate into that. So to find the slope of that tangent line, I plug my known x value into my derivative. So 2 times 2 minus 2 is 2. So the slope of the tangent line at 2, 1 is 2. I have my point, I have my slope. Let's use the equation. So we have y minus y1. There it is again, point-slope equation. My proper substitution, here's y, here's slope, here's x. Y minus 1 equals 2x minus 4, bring over the 1. So y equals 2x minus 3 is the tangent line at 2, 1. So what does that mean? Okay, what does it mean to have a tangent line? What does it mean to have a derivative? Okay, so what we're going to look at is graphically. So recall that our function was x squared minus 2x plus 1. That's seen here in black. It's important to remember that when we took the derivative of this function, we got 2x minus 2. What that means is that's the expression to find any slope on the domain of this function. This is a polynomial function, so every x value works. No matter what number I choose, it'll work in that function. So that 2x minus 2 is the expression to find the slope of any tangent line of this function on the interval of any x. So the red line is the actual tangent line that we found, 2x minus 3. So here's the original function I plotted. Do you remember that the point we found when x was 2, we got y to be 1? Look where the intersection point is. So the tangent line and the function will intersect, okay, at the point of interest. So if I give you x equals 2 and we plugged it in, we got 1, tangent lines only intersect something one time. So there's the point of intersection, and there is the tangent line. It's important to realize that the point of intersection was 2, 1, like we talked about. And please remember that different x's are going to give us different tangent lines, different slopes. So let's look at another example using the same function. We're using the same function we did before, but we changed the x to be x equals 0. So really quickly, when we plug 0 into our function, 0 squared minus 2 times 0 plus 1 is just 1. So when x is 0, y is 1. There's my point of interest. So that's where the tangent line and the function are going to intersect at 0, 1. So once we do that, remember the derivative was 2x minus 2. This expression will not change for this function. That derivative will always be 2x minus 2, so this will always be the expression to find any slope of this function. So I've got my point, I've got my derivative, but I need the slope. You plug your x into this derivative to find the slope. So 2 times 0 minus 2 is negative 2. So here's our slope, here's our point. Point slope form. We plug this in, 1, 0, and negative 2. So we get the line of y equals negative 2x plus 1. And notice how that's different than the previous example. So let's look at another graph. In the last slide, I put all the graphs together. I've got my x squared minus 2x plus 1 in black. The red line was the first tangent line when x equals 2. We had the line 2x minus 3. The green line represents the newest equation. Remember when x was 0, y was 1. And if you look at the point of intersection of the black and the green graph, it's at 0, 1. The slope was -2, okay, and the y-intercept was 1. So down 2, right 1, there are two different tangent lines to the same function. So it's very important to remember that if you choose different x's within the same function, you're going to have different slopes, so that's going to represent different tangent lines to your function. So if you guys have any questions or comments, again, you can email me, nicholas.bennett@dc.gov, or you can go ahead and make your comments below. We'll see you next time, guys.